Good morning, everybody. How is everybody's weekend?
How was your weekend?
It was not bad. It's not bad.
What did you do?
Hung out, watched some Netflix, the usual.
Netflix and chill?
Yep.
Hey, we were there for that one. Sunday morning.
Oh, no problems. So, agenda for the day: we're going to review operators, compound operators, review scanf. Then we're going to talk about conditional flow statements. We're going to work on day 8 in the class again, just make sure everyone gets that figured out. Make sure everyone's on the same page for scanf, and we're also going to have a short daily assignment for today too, but you shouldn't have any problem with that if you understand scanf. So, questions, concerns right now?
We're going to go over just some stuff we were doing last week, right?
Yes, we are going to continue working on day 8, which was Friday, which was the scanf and the compound operators. Alright, so quiz 2 is going to happen on Friday, and remember assignment 2 is due on Wednesday. Assignment 2 is the one where we're computing sales tax, so we take the total, or we take the subtotal, we prompt the user to input the subtotal, we prompt the user to input the tax rate, and we output the total. So that's due at 11:59 p.m. on Wednesday. So that's conditional flow. So, going to review assignment operators really quick. I got a program around here I can use. Let's see, that'll be good. So just remember that we can say int a equals 10. And then manipulating a, we can say a equals a plus 10, which will add 10 to a and store the result in a. Or if we want to simplify that, we can do a plus equals 10, which just is the exact, so these two statements are exactly the same. It's just this one's shorter. So again, this is something we call a compound operator. It's basically combining the plus and the equals into one statement. So we can do that with any of our math operators. We can subtract, we can multiply, and we can divide. So that's basically all there is to math operators, or at least the basic ones. There's a couple more that we'll take a look at later, but that's all you really need to know for right now. So, going back to talking about scanf. So scanf was the main thing we talked about on Friday. And again, basically what scanf does is it reads input from the user on the terminal and interprets that input and stores it into a variable. So real quick, we can read in an integer by saying scanf %i, same format identifier as printf, it's just we're going in the other direction, and then we say an ampersand, and then our variable that we want to store it in. So remember that we can do this with multiple types and multiple variables in one. We can also say, we could say int b. All we have to do is extend our format string out and say %i again, and then expand our list and say %b. And we can use different types, just the same with printf. We have to make sure that our format identifiers match what kind of variables we have, or which type of variables we're providing to scanf. So we have to make sure that when we say %i right here, that this variable right here is an integer. And if we did something like this, and we were trying to read in a character, odds are this would break, and it would give you input that you didn't necessarily want to have. So just make sure, again, as with printf and scanf, that you're always matching your format identifiers with the variable type that you're trying to read in or print out. So one thing that actually came up on Friday that I forgot about is something interesting. So let's say we were doing this. We had an integer and a character, and we'd say char cb. And then we wanted to, so we're going to read in one integer and one character. And we'll just print them out really quick. So something actually is interesting. Actually, that's kind of interesting is going to happen here. So we're going to say 10C. That actually worked. Didn't expect it to. Let's do it a little differently, actually. Yeah, that's what's going to happen. Alright, that's not a C, that's a B. Not that one, this one. So 10. Alright, so what happens in this program, actually, is something interesting. So when you actually type, you type the first letter, or you type the first number, and you push 10, and you push Enter. Now what actually happens is, so the exact characters that are given to the program are 1, 0, and then /n. So what actually ends up happening is the first scanf interprets that 10, but the second scanf sees that /n, that new line, and it reads in the new line into B. And so that's why we're kind of left with this. So this is where we input 10, and this is our actual, what is this here? Then this is where we output 10, and then we output a new line, because when we inputted it, when we typed in our 10, that new line registers as the second character. So the ways we can get around that is we can just do our scanf entirely on one line. Like the first time I wrote it, it actually took that space. There wasn't any new line, basically. The new line was still in the buffer, and we didn't really interpret it. And so I use the word buffer, and whenever we read something into a program, or when we type something into a program, or print something out, there's basically an intermediary between the terminal and when you see it. And depending on a couple of different circumstances, it might not always be, your program might not always print something out exactly when you want it to if you don't have a /n at the end, or if you do a couple of different things. And it's not really important now. But just to keep in mind, if you want to get around that, if you have that new line stuck in your buffer, you could do something as simple as just copy your scanf and run it twice. So basically the first time you run it, it's going to read in that new line that you left it up here with your first scanf, and then it'll read in the actual character that you type in the second time. So I'll rerun that again. 10C. So now we can see it printed out correctly. So it's just it's a little thing you have to get around if you do have problems where you are not getting your character input correctly. Just keep that in mind, that you might have to read it in twice just to clear the buffer of any trailing new lines. So that's scanf right now. Does that kind of make sense to everybody how scanf works? We're going to work on it, continue working on it in class today, and make sure we're all on the same page here. So the main thing I actually want to talk about today is conditional flow statements. So during our program, we need to make decisions based on kind of the environment or things that exist on the system, things that are provided to the program. So we can do something like this. We can say if left parenthesis and then conditions, right parenthesis, left bracket, and as many statements as we want to run, and then right bracket. So essentially how this works is if thing inside the parentheses is true, then we're going to execute everything inside the brackets. So we'll just go ahead and set, undo that, a equals to 10. So we can say if, I should probably talk about this too. So we have quite a few, so how do we determine if something is true or not? So we have a couple different it's logical operators that we can use to determine whether or not something's true. So it's very, very standard. So we have something like 10 is less than 100. So that would be true. But 10 is not less than 9. So that would be false. So if we put 10 is less than 100, or variable name is less than variable name inside those parentheses of our if statement, then it would be true for this statement, and it would run the statements inside the brackets. But for this statement, of course, that's false, and it's not going to run the statements inside those brackets. So we can also do greater than. We can do. Oh, I'll just write them all. We got less than, greater than, less than or equal to, greater than or equal to, or equal to. So one of the really confusing things with C and a lot of other programming languages is there's a difference between assignment and equality. Now a lot of times in a math class you might see something like this, and that's something that's assignment. And in a lot of other programming languages that might also be assignment, and this might be equality. But in C, equals is assignment, so we would do something like int a equals 10, so that's an assignment. But if you want to check and see if a is equal to 10, you would say a equals 2 equal signs 10. So going back over to our program here, let's say we want to check and see if a equals 10. So we just say a equals 10. And then our left bracket, and then we can say, we'll just say puts a is 10. So we can see that the program successfully detected that a was 10. Now if we go back and we change a to, let's say, 9, we can see it doesn't print anything because a is obviously, or 9 is obviously not equal to 10. So just combining like scanf and printf, we can say something like scanf. Well, I gotta say int a, declare our variables, and then say %i so it'll wait. It'll allow us to basically store a. Yep.
Is there an else that we can put at the end of statement?
Yep, there sure is. So we can say 10, and it's equal to 10. But if we give it any other number, obviously it's not equal to 10. So let's say we want something to run when it's equal to, but we also want something to run when it's not equal to. Essentially, we can say else bracket like that. So when we have an if statement, when we close our right bracket, it's optional that we can say else. If we want to, we can say else, and the statements inside the two brackets will run when, in this case, when a is not equal to 10. And the else is completely optional, but in order to use the else statement, you have to have an if to start out with. So in this case, we can run it. We can say 10, a is equal to 10, but if you say 9, then it'll say a is not 10, clearly. Yeah, so that's pretty much it for if-else statements. We'll talk about, there's another statement called else-if, so we can chain multiple if statements down, so we can have multiple true cases and then our one catch-all case at the end if we want to do so. So that's pretty much it for if statements. Remember, we can have a bunch of different operators we can use. We don't just necessarily have to use equals. We can use less. Where am I here? Less than. We can use greater than. We can use less than or equal to, or you can use greater than or equal to. So those are the operators we can use right now. And going forward from this, we can chain multiple conditions. We can chain multiple things, so we can test multiple equalities or inequalities later on. So for right now, I think what we're going to do is continue, where is it at here? So we're going to continue working on day 8 in class. So again, we're going to read in an integer, character, and floating point number, perform a math operation on each of them, and print the result, and submit to day 8 in class. So then, for today, we're also going to prompt the user to guess a number, and then we're going to notify them if they guessed correctly, and notify them if they guessed incorrectly. I should say that too.